Okay, let's continue. I once again did not want to record this because I don't want to go through my schoolwork, but I have to. So, let's get to it. Alright, last time we ended off on slide 12 of 56. Alright, also, you're about to see me fail pretty spectacularly. One sec. So, you know very well I'm gonna get everything that's available here. Just you watch. Anyways. So, slide 12, vent connector length. Length of vent connector. Wow, thanks for labeling that. Preferred is about like less than 5 inches. I think that's what it means. Marginally acceptable, 5 to 10 inches. Suspect, more than 10 inches. It literally says suspect. Look, 20 rupees. That's not that bad. Pretty good. General rule. Maximum of 1.5 inch horizon. What? Horizontal run per 1 inch of vent connector diameter. I don't even know what these symbols are anymore. Is it 1 or 2 that represents an inch? Horizontal distance should not be more than 75% of vertical height. Anyways. So whatever all of that just meant, let's actually read the notes, the material. The greater the horizontal length, the more difficult it is for exhaust gases to travel. General rule. 1.5 foot maximum horizontal run for every inch. Oh, look at this. Here, I thought I could get them all with a single bomb arrow. Nope. 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 Nuh-uh. Not happening. Nice try. And then I said, you know what? I'm using too many bomb arrows. So let me reload. And then, I reloaded back here. Now I gotta do all that again. Good going, me. Real smart thinking there. Anyways, yep, improper slope. 1/4 inch per foot is minimal. Can lead to condensation and spillage. Vent connector too long. The horizontal run of the vent connector should be as short as possible. Causes. This is an installation issue. I almost said installation house. This is an installation issue. Implications. Exhaust spillage into the house. The greater the horizontal length of the vent connector, the more difficult it is for exhaust products to make it from the appliance to the outdoors. Strategy. Look for vent connectors to be less than 5 feet long. Sorry, I'm just keeping an eye on the screen. See? Last time I only got 20 rupees. Now I got like 22. So I benefited 2 rupees by loading back the save. Anyways, strategy. Look for vent connectors to be less than 5 feet long. Where they are 5 to 10 feet, the situation may be acceptable, but it's marginal. Vent connectors more than 10 feet long should be described as suspect, and investigation by a specialist should be recommended. Okay, see, I actually was smart here this time and I actually saved the game. And this time I also decided, yeah, I'm not going to waste my time with bomb arrows. I'll just sacrifice the bow durability. A rule of thumb some people use is 1.5 foot maximum horizontal run for every 1 inch of vent connector diameter. Poor connections. So this diagram here, look for 3 screws at each connection point. Watch for disconnected vent connector sections. Lack of support can result in improper slope and low point where condensation can collect. Poor connections. Sections of vent connectors should be well secured. 3 screws is a common rule of thumb. Other connection mechanisms may be acceptable. Causes. Poor connections are usually an installation issue. Implications. The implications are, again, leakage of combustion products into the home. Strategy. Visually examine all connections to ensure that they are intact. Sags or changes in direction often indicate a poor connection. Watch for disconnected vent connectors. These are most common where the vent connector joins the chimney. Another common problem area is at the water heater connection. Check the entire circumference of each connection. I also just had lunch. So we have a diagram here. This vent connector is poorly manifolded into the connector of the furnace. It goes up and turns back down, which is not conductive to the discharge of gases. Recommend improvement. Vent clearances. So it shows like a B vent connector, typically 4-inch diameter, 1-inch clearance required, B vent cross section, 6-inch clearance required, single wall vent connector, bracket cross section. 6-inch clearance on vent connectors and 1-inch on B vents. Vent connectors should not go through walls or ceilings to connect to chimneys. Inadequate clearance from combustibles. Most vent connectors are 4-inch diameter single-wall steel or aluminum pipes. Generally speaking, look for a 6-inch clearance from combustibles on vent connectors unless a B vent is used. With a B vent type vent connector, a 1-inch clearance is all that is required. There are double wall vents with an airspace between the walls. Causes. This is an installation issue. Implications. If the clearance from the combustibles is not adequate, there is a fire hazard. Strategy. Watch for the clearance from walls and ceilings. Many authorities consider drywall to be combustible because of the paper surfacing. Alright, all in brackets, should not go through walls or ceilings. Vent connectors should not go through walls or ceilings to connect to remote chimneys. While these may be allowed in special circumstances, they should be written up as suspect. Combustible clearances can sometimes be reduced with protective materials. See, I don't know if it's just the internet twisting the word suspect or not. Like in a formal sense, like in an actual teaching sense, shouldn't it be suspicious instead of suspect? Anyways, there's a pretty nasty looking diagram here. There is quite a bit of backdrafting and leakage of combustion materials here. It just shows the top of a water heater and it's pretty rusty, pretty gnarly looking. Another diagram. This vent connector is too close to the plumbing insulation. Okay. Another diagram. Did we say combustible clearances? Triple exclamation points here. Size of vent connector. The vent connector diameter should match the size of the flue collar. Yep. Not flu as in the common cold. F-L-U-E. If the vent connector is too large or too small, condensation or spillage could result. Note, the vent connector size should, underlined, should increase where applications are manifolded. Alright, so check the size of the vent connector relative to the size of the flue collar on the appliance. Steel and aluminum are the most common vent connector materials. Vent connector too small or too big for the water heater. The vent connector should usually be the same size as the flue collar on the appliance. Where more than one appliance is manifolded, the vent connector size should increase. Cause. Improper vent connector sizing is an installation issue. Implications. The implications are spillage of combustion products and or condensation. Strategy. Check the size of the vent connector relative to the size of the flue collar on the appliance. If they are different, You should recommend that this be checked during regular servicing. Where the vent connector appears to be sized differently, check carefully for spillage during your operating test and look for evidence of condensation along the vent connector, at the bottom of the chimney and the water heater. Why did I take this class? Okay, another diagram here. Water heater exhaust discharging into basement. This is a potentially deadly situation and should be immediately repaired. The occupants of the home should be notified of the immediate danger. In a situation like this, we should turn off the gas supply to the appliance as part of our duty of care, or turn off the pilot. You know, something I find strange about these school presentation PowerPoints, there's slides like these that have a picture and then a description like what I just read out loud. Shouldn't we be at a point where we can have like a video playing? Not like an actual video where you have to press play, kind of like a GIF, but longer, kind of demonstrating what the actual scenario is. Instead of just a picture, it's like, what am I even supposed to look at? Water heater exhaust discharging into basement. That doesn't seem like what I'm looking at. I'm just seeing rusty pipes. Anyways, ooh. See, like this one. I'm seeing a bag covering some of the tubes attached to the water heater on top. Melted poly on water heater exhaust flue. It's like, what? Melted poly on water heater? Ugh. Okay. Ooh, this one has a lot to read. Chimney/vent connections. The smaller appliance vent connector should vent into the chimney above the larger one. Excuse me, the moment I start reading things, I start to yawn. What am I even doing in game anymore? Did I get the Korok yet? No? Vent connectors from multiple flues should connect to the chimney one above the other, with the larger input appliance venting below. The exhaust from the larger appliance could choke off the exhaust from the smaller if it is below it. Power vent connectors combining with natural draft appliances are not ideal. Recommend further investigation. If vent connectors are manifolded into a single vent connector before the chimney, the single vent connector should be larger than the two. Poor manifolding. Multiple vent connectors connected to the same chimney flue should connect to the chimney one above the other, with the larger input appliance venting below, bracket before, the smaller. Causes. This is an installation issue. Take a shot every time I say that's the cause. Implication. Again, exhaust spillage is the implication. That's really how this stuff is phrased. Strategy. It's good practice to put the smaller appliance vent connector directly into the chimney above the larger appliance. The exhaust from the larger appliance could choke off the exhaust from the smaller appliance if the smaller one is below. Alright. Manifold close to chimney. Where the appliance vent connectors are manifolded, into a single vent connector before they go into the chimney, make sure the single vent connector, bracket downstream of the connection, is larger than the other two going into it. Also, the vent connectors should be as close to the ceiling level as possible while still maintaining combustible clearances. Alright. Forced or induced draft appliances. One has to be careful combining power vented, bracket, forced draft or induced draft appliances with natural draft applications. Appliances. Under some circumstances, the fan from one appliance can push the products of combustion out through the draft hood of the natural draft appliance, especially if it is idle while the power vented appliance is working. Again, An analysis of when this is acceptable is beyond the scope of the inspection. Recommend that the situation be checked during regular servicing. Ugh, not even halfway done this presentation yet. I'm now on slide 23 of 56. Vent connector extends too far into chimney. If the vent connector extends too far into the chimney, proper venting may be prevented. Check for this in the chimney cleanout with a mirror. With a mirror was bracketed. Use you. Whoops. Use you. Nope. No wonder I read that wrong. It says use you flashlight. I'm pretty sure that's supposed to say your. Use your flashlight and mirror to look up the chimney, not always visible. Vent connector extends too far into the chimney. If the vent connector goes too far into the chimney, it is effectively choked off, and you can't vent properly. Causes. Take a shot. This is an installation issue. Implications. This could allow products of combustion to enter the house. Strategy. If there is a chimney clean out, use your flashlight and mirror to look up the chimney. If you should not be able to see the vent connector projecting into the chimney opening, effectively reducing the chimney diameter. Check from above. In some cases, you can look down from the top of the chimney, although you can't always see far enough down to determine whether the vent connector projects too far into the flue. On some installations, you won't be able to tell whether the vent connector goes into the chimney too far or not. Excuse me. Ugh. Well, at least sometimes there are slides that are nice and quick, like this next one. Just a diagram and one sentence. Actually, two. Whoops. Two appliances should not discharge at the same height from different sides. Smaller unit must be on top. Oh, the next one is literally the same picture, but highlighted. Highlighted the areas to focus on. They literally photoshopped some of the tubes to be yellow. Possibility of exhaust gases backdrafting when furnace is operating. Did I just say furnace? Next one. Another poorly sloped vent with a big arrow pointing to it. Function of the draft hood. Breaks the draft from the burner to maintain a constant airflow through the burner and not disturb its operation. Deflect drafts coming down from the chimney to disturb or blow out the flame. Can you see the following? Evidence of spillage. Look at the burn marks around the draft hood. Poor slope and support at mid-span. Oh boy, this one has a lot to read. A lot. Well, actually, it's not too many. I've had slides that have had more to read than this. And something on top of the... Something on top of the boiler that looks like a dusty UFO. Spillage at the draft hood. We touched on this a number of times as a symptom of several problems, but it's important enough to treat it as a condition by itself. Functions. Let's review the functions of the draft hood. Bracket, draft, diverter. Add air to maintain chimney draft. Draft hoods break the draft from the burner to maintain constant airflow through the burner. If the draft hood wasn't there, as the draft is established in the chimney, more and more air would move through the burner. This would disturb the burner operation. As the velocity up the chimney changes, more air can be drawn in through the draft hood without disturbing the burner. Deflect downdrafts. A second function of the draft hood is to deflect downdrafts coming down the chimney. This prevents them from disturbing or blowing out the flame at the burner. Causes. Spillage at the draft hood may indicate, quite a number of bullet points here, may indicate inadequate combustion or dilution air, a mismatch in the sizing of the chimney or vent, negative air pressure in the house, an obstruction or downdraft condition, poor slope, Excess vent connector length. Poor manifolding of multiple appliances extending far into the chimney. Implications. Literally just says, we've talked about these. That's all the implications say. We've talked about these. Strategy. While the water heater is operating, check for spillage at the draft hood. A little spillage on startup for the first 2 minutes is not a significant problem, but after the water heater has been running, there should be no spillage. Test not conclusive. There may be no spillage on the day you test the water heater, but there could be spillage under different weather conditions. Jeez, it's already been 20 minutes. Only a third way there. Corrosion on top of heater. Again, I assume that's supposed to say top, but it's spelled T-O-P-E. Corrosion on top of heater. Leak from the pipe. It looks like backdraft problems. Alright, a diagram that is disconnected vent connector. Another diagram of a lot of rust, not only on the bottom of the water heater, but also on the floor leading to the drain. Pretty severe leaks on this water heater. It needs to be replaced. This water heater has not been drafting properly. The condensate from the exhaust has rusted the top of the unit. I know it's just physics of our world, but don't you think by now we should have come up with a solution to metal rusting in water? Like, isn't there a way we can just prevent that altogether? I feel like that's something that's possible. Anyways, fuel supply and venting systems. Oil-fired water heaters. We are now on to slide 34. Oil-fired water heaters. We will look at oil storage tanks, oil-filled vent pipes, oil supply lines, oil filter, oil burner, primary controller, barometric damper, never heard that word before, vent connector. Ooh, a lot of words on this. Oil storage tanks, clearance from oil burner. So oil tank, oil burner, oil water heater, these things are labeled. Actually, I think that's 10 feet. 10 feet clearance required. 5 feet in some areas. Concrete block walls are sometimes installed to reduce the required clearance. Common problems with storage tanks include poor location. Well, it says common problems, but that's the only problem listed here. The oil tank and any burner should not be installed within 10 feet of each other, 5 feet in some jurisdictions. Oil tanks in garages or outside should be protected from cars. Steel posts filled with concrete are often used. Causes. Poor tank location is an installation issue. Implications. A malfunctioning burner. Yep, I almost thought that was spelled wrong. Nope, it's spelled right. A malfunctioning burner could ignite the oil in the tank if the tank is too close. The implication of a tank being hit by a car is an oil spill and possible fire. Strategy. Note the distance between the tank and the burner. In some homes, a concrete block partition may have been constructed to efficiently increase the clearance. Check the garage tanks. Check that garage tanks are not susceptible to vehicle impact. Alright, oil storage tank leaks. A bunch of things that are labeled. Watch these locations, especially for oil leaks. Pointing at the oil gauge. The part of the oil tank that has pipes connected, the bottom of the tank with a valve, the shutoff valve. What am I doing? It's labeled. Common problems with storage tanks include Leakage, rusting. That's it. Leaks are often caused by rust. Water in the tank, bracket from condensation, settles to the bottom of the tank since water is heavier than oil. Implications. The leak may start out small. Due to the odor of oil, homeowners usually detect this. A small leak is a nuisance unless the tank is outside, where it is an environmental problem. If undetected or unrepaired, the leak could progress, flooding the area around the tank and damaging finishes. If the oil flows towards the burner, a fire could result. Replacement of the tank is usually necessary, depending on the size and location of the leak. Strategy. Check the underside of the tank and floor below the tank's most likely locations. Leaks may also occur around poor connections or vent pipes, filter, or burner. Fuel oil has a distinctive odor. A smell does not always indicate a leak. I said owner. Alright, buried oil storage tank. Clues that the oil tank is buried outside. You can't find one inside. Pipe with oil filter and or shutoff valve emerging from the foundation wall. Filter pipe and or vent pipe is not right next to the wall. Note: in some communities, oil pipelines pump oil directly to the house. From the inside, the clues may indicate an outside buried tank, but no filter or vent pipes will be visible. Common problems with storage tanks include underground. And that's it. Implications. Leaks from a buried tank are environmental concerns and are beyond the scope of a home inspection. Existing abandoned tanks will also require removal in many jurisdictions, even if the conversion was carried out by a previous owner. Bracket, very expensive if there is soil contamination. Strategy. Locate tank. Try to find the oil tank inside the house first. Tanks are typically inside the house near the area where the oil pipes go through the house walls. If the tank cannot be found in the basement, check the crawl spaces also. Follow supply line. If necessary, follow the copper fuel supply line back to the burner. Fuel line should be buried in or below concrete slab floors. Bracket. Sometimes a patched trench is noted, or embedded in motor which fills the joint between the foundation and floor. If the fuel line goes through the wall, there may be a buried tank. Neighborhood oil piping. There were neighborhoods developed in some areas in the 1950s and 60s with oil piped in from large distribution tanks. The oil was delivered to the house on a demand basis, much like natural gas. These systems should not be confused with buried tanks. These homes typically have a metering device and a shutoff valve on the fuel line where it enters the house. Okay, undersized fuel lines. Cold oil is viscous, so thinner oil is used with exterior oil tanks. The larger pipe between the tank and the house reduces the chances of the line getting clogged up. A 2-inch steel line is used between the tank and the house, and for another 4 feet inside the house before switching over to the smaller tubing. Let me take a sip. I have a milk tea here with me. Common problems with oil fill lines and vent pipes. Leaks, missing caps, damaged / corroded. Implications. Leakage or spillage, water entering the tank. Common problems with oil supply lines. Bracket, carry oil from tank to water heater burner. I don't know why I paused there. Carry oil from tank to water heater burner. Anyways, common problems. Leaks, corrosion / mechanical damage, unprotected, undersized. Implications. Fire hazard, high cleanup cost, damage to lines, fuel starvation at burner. Notes on picture. With outdoor units, the fuel thickens in cold climates and doesn't flow well into the house. 2-inch steel line should be used for 4 feet into the house before using thinner lines. You know, every time I read out loud leaks, I think back to that scene in The Menu where, you know, Tyler was called up to cook. And he's just like, leaks. He's cooking some leeks. That's all I think about every time I say the word leak. Anyways, oil filter. Common filter problems. Leak, dirty, missing. Implications. Improper burner function, reduced efficiency, clogged fuel line. Inspector can't tell if filter is dirty at an inspection. Filter is, however, an annual maintenance item. Common oil burner problems. Dirty, inoperative, leaking, incomplete combustion, excess noise/vibration, too close to combustibles, refractory problems. The nozzle and filter cannot be checked during inspection. Look for other evidence. Color of flame should be orange if all in proper working condition. Incomplete combustion can't result in black flame tips or additional smoke. Recommend service. Burners normally noisy, but note any high-pitched or excessive noise. Many burners normally require 24 inches clearance from combustibles. Implications. Inefficient burner, higher heating cost. Inoperative burner or no hot water. Soot buildup, incomplete combustion. Deterioration, of the burner components. Combustible clearance/fire hazard. Oh yeah, see how this guy attacked me here? Damage to the remainder of water heater. Same as previous page. The nozzle and filter cannot be checked during inspection. Look for evidence. Oh. Yeah, everything just says the same. Great, one less slide for me to read. Now, if you what are these called again? Stalazalphos. If you guys don't mind, I have a Korok to pick up. And also, I'll take your tail. Pause. I don't know why I pulled out the Master Sword as if I was about to attack them. Maybe I was. But they knocked me off, so, well, they get to quote-unquote live another day. Anyways, so, flying to the next Korok. Refractory/fire pot. Look for cracks or deterioration of the refractory material. Refractory problems. The refractory or fire pot contains the burner flame and directs the heat up to the heat transfer area. Refractories may be masonry or ceramic fiber, common to new systems. Refractories may crack, crumble, or collapse. Cause. The deterioration takes place naturally as a result of the hostile environment. Inherent flaws in the refractory or overfiring of the burner may accelerate the deterioration. Implications. The flame will not be properly contained. This can be a fire hazard. Sometimes the refractory alone can be replaced. In some cases, the entire water heater has to be replaced. Strategy. Look for evidence of scorching or overheating around the base of the water heater. If you can see in an observation port, you may be able to see whether or not the fire pot is intact. Where it is suspect, recommend further investigation. Ugh, there's a picture here that really... At first I thought this looked like the milk jug, but no, now I can make out there's scorch marks on the outside of the water heater. Look at the scorch marks. This burner needs to be serviced. primary controller. Primary controller ensures that the burner has ignited. If the controller does not see heat within 60 to 90 seconds, it will shut the burner. Common problems: missing, inoperative, tripped. Implications: risk of oil flooding the combustion chamber, risk of explosion, no hot water. The primary control could be tripped if the burner is malfunctioning. Do not reset if this is an oil puddle. If there is an oil puddle or if you cannot see inside. Do not reset is all bolded, so hear that, folks. Do not reset. Do not reset this if there is an oil puddle or if you cannot see inside. Alright, more about the primary controller. Primary controller, primary relay or stack relay, pointing at the reset button. Oil water heater exhaust flue, bracket vent connector. Yeah, it's just labeling the picture. The primary controller checks the exhaust flue for heat. If it doesn't find any, it assumes that the oil burner is not ignited properly and shuts it down. If the reset button should only... Wait, there's no if there. The reset button should only be pressed once if the burner fails. If the burner fails to come on. Bracket, otherwise unburned oil will accumulate in the combustion chamber. The illustration shows an older setup. Most modern oil burners have a photocell on the burner to verify ignition. Do not reset, this time bolded and underlined. Do not reset if the controller... Jeez, I cannot read to save my life. Do not reset the controller if there is a puddle of oil in the refractory. An explosion can occur. If there is no oil puddle, you can attempt to reset the primary controller once. Sometimes soot on the photocell will prevent it from seeing the flame, which can shut down the burner. Let me just turn down the brightness here real quick, because it is getting late. You know, you can definitely tell winter is ending, because normally around this time, it's 5:30 p.m. right now. Normally by this time it'd be pitch black outside, but no, it's still bright outside, but it's just starting to get dark. So let me turn down the brightness of my screen so my eyes don't get singed. You know, I'm sitting here talking about how winter is almost over when, as of me doing this, New York is experiencing a huge winter storm, one of the biggest in like a decade. One of the biggest ever recorded from what I'm seeing online. Damn, poor New York. You know how screwed we would be if an actual apocalypse happened? You know how screwed we would be? Not only would there be no power, so nighttime would be pitch black. We take for granted how important streetlights are. But also, survivability up here in the Great White North would be impossible. There would be no one shoveling the snow. Anywhere that has snow during the apocalypse would be absolutely buried. No heat, no government cleaning up the snow, the streets. Yeah, anywhere where it snows during an apocalypse would be absolutely inhabitable. Anyway, so, moving on. Barometric damper, or barometric, I don't know. Barometric damper is a draft control device that helps ensure exhaust gases make it up the chimney. Common problems with a barometric dampers. Rusting, inoperative, Okay, I don't know why I'm seeing this word weird. Misadjusted. The way I'm reading this word, misadjusted. I don't know, for a second I broke down the word misadjusted into 3 parts. Misadjusted. I don't know what's wrong with me. Inadequate draft air spillage. Rust can obstruct the movement of the damper. If stuck open, it can allow exhaust products to enter the house. If stuck closed, if stuck closed, it can overheat the vent and cause poor burner performance. Home inspectors should test the damper movement by gently pushing it open. Implications. Improper venting of exhaust products can affect combustion and reduce efficiency. Rust can obstruct movement of damper. Damper stuck open or closed. Spillage of unwanted combustion. Barometric damper. Bracket draft regulator. So there's a diagram here. Damper closed. Damper open. Counterweight, draft air, view through flue. Barometric damper, draft regulator, exhaust flue. Anyways, note, not all oil-fired water heaters will have a barometric damper. Ensure damper is closed when burner is off. When operating, check for spillage at damper, any hot or wet gas, or black soot. Vent connectors. Common problems include rusting, poorly sloped, poorly supported, excess length, inadequate clearance from combustibles, loose connections, too small, improper material, dirty, poor insertion into chimney, poor manifolding, obstructed. These are the same conditions as vent connectors for gas-fired hot water heaters. See gas vent connectors for implications. Some differences between gas and oil vent connectors. Exhaust products from oil combustion are more corrosive, causing more rust. Higher exhaust temperatures from oil combustion require higher combustible clearance, 9 to 18 inches. Flue gas temperatures below 350 degrees Fahrenheit or 177 degrees Celsius result in corrosive condensation. Look for patches used at seams and elbows where prior rust occurred. Exhaust flue support. Support every 4 feet. Slope flue 1/4 inch per foot up towards the chimney. Poor slope can result in backdrafting of combustion gases. I'm surprised that counted just now, that Korok. You saw how strong the wind was blowing against me. Poorly sloped exhaust flues. Slope is critical to the exhaust flue because the products of combustion may be able to move to the chimney under gravity. Causes. Building settlement can change the slope of an exhaust flue. Many installations have incorrect slope originally. Poor support can also cause improper slope. Implications. Poor slope can result in backdrafting of combustion gases or inadequate venting of combustion gases. These are life safety issues. Strategies. Measuring the slope. The exhaust flue should slope uphill, away from the water heater at a slope of 1/4 inch per foot. Until you get used to eyeballing the vent slope, you may wish to actually measure it. A 4-foot spirit level can be used to check the slope. Exhaust flue length. An elbow is equivalent to about 10 feet of straight flue. General rule. Maximum flue length should be 10 feet plus 2 elbows. Well, we're almost done. I'm on slide 52 of 56, and I see the next 2 slides are just diagrams. Well, actually, no. The next 2 after the next slide. Excessive flue length can result in poor drafting and possible spillage. Excess length. We mentioned that the oil burner was a forced draft burner. This may lead some to believe that the burner pushes the exhaust products out of the exhaust flue. This is not necessarily true. The exhaust flue can't be too long, or its own internal resistance to movement of the exhaust products may overcome the burner draft. 10 feet is a commonly accepted maximum length. Causes. Installation error is the most common cause of excessive lengths of vents. One of the most common reasons for excess vent length is too many elbows. The friction loss in an elbow is equivalent to 10 feet of straight exhaust flue. A system with 3 or 4 elbows will usually have an excessive vent length, regardless of how short the actual run is. Excuse me. The implications. The implication of excessive vent length is poor drafting and possible spillage of combustion gases into the house. This is a life safety issue. Strategies. As a rule of thumb, you can use a vent length maximum of 10 feet plus 2 elbows. Common sense applies here. If evidence of poor drafting of back... Jeez, what is a sentence? If evidence of poor drafting of backdrafting is visible along the vent, such as corrosion or corrosion on the face of the water heater above the oil burner, or evidence of poor combustion in the combustion chamber, when the vent length should be checked. That was all one sentence. Experience helps. Again, given time, installations can be checked and excess length vents identified before even looking at the water heater. For first inspections, it is better to actually measure the length of the flue. Exhaust flue clearances. Exhaust flue cross-section. Cool. Whatever. 9-inch to 18-inch clearance to combustible material is required for single-wall oil water heater exhaust flues. Higher exhaust gas temperatures when burning oil. Inadequate clearance to combustibles. Many inspectors reveal inadequate clearance to combustibles. Exhaust flues, especially on oil-fired appliances, are hot enough to ignite many combustibles, yet people treat exhaust flues as a convenient place to hang storage. I mean, I guess I'm guilty of that as well, because my family, we hang laundry in the room where the water heater's at. So make of that what you will. Causes. Installation error, e.g. a bracket, e.g. someone building a wall after the water heater has been installed, is the most common problem. However, homeowners storing combustibles too close to the exhaust flue can cause this problem. Well, we don't store it too close, you know? It doesn't touch the water heater. Implications. Improper clearance to combustibles can result in fire. Strategies. The clearance to combustibles for a single wall exhaust flue from an oil appliance is 9 to 18 inches, depending on the appliance used in your jurisdiction. You should verify this number for your areas. Oh, a very long tube that reaches really far into the dark that looks like something out of the Backrooms, which, by the way, we did get a release date for the Backrooms movie. Can you believe? Here's a vent extending behind the wall that goes way too far. Hold on, let me look it up real quick, because I saw it on the Kane Pixels Discord. Oh, I didn't see this yet. We actually did get an official teaser as well. Anyway, so, Backrooms, a film by Kane Parsons, by A24. January, February, March, April, May. Okay, 5th month. May 29th, 2026. Sweet. Ooh, I'm gonna watch that teaser after I'm done doing this. I feel like we really are getting back into a good era for movies. Then again, you know, woke garbage hasn't completely left our society yet. But we're getting there. It's definitely getting better. Alright, next slide. Carbon monoxide detectors. Okay. And lastly, electrical water heaters. Covered in the electrical inspection course. Okay, and that's it. That's all of this presentation. So that was 56 slides. Oh, the next one's even longer. The following week's material is 58 slides. Let me just do a quick glance. How much is there to read? Okay, that one's not too bad. Oh, this one, there's a lot of words here. And here, the next slide. This one has a good amount to read as well. Okay, this is one that has a lot to read, I see. Oh my, oh. Yeah, this one has a lot to read. What am I doing with my life? Well, may as well read as much as we can in the 9.5 minutes we have left. Alright. Conventional tank type water heaters. Look at conventional gas, oil, and electric water heaters. Conventional tank type water heaters. Common conditions: inoperative, inadequate capacity, leaking, rust, gas burner cover missing, damaged tank, clearance from combustibles, insulation obstructing combustion air, poor location. Common conditions: low water pressure, noisy water heater, temperature/pressure relief problems, baffle collapse, tank not stable, hot/cold reserved, no insulating valves, drain valve problem, propane water heater in low area, expansion issues. Alright, there's a picture here and it's just labeled inoperative. Causes. There are several possible causes for no hot water. These include: oil heater is out of fuel, fuel supply is shut off, bracket gas or oil, burner problems, ignition problems, electrical supply disconnect, electric element is burnt out, faulty controls, bracket thermostat energy cutoff. Thermostat, comma, energy cutoff. Yeah, clearly you could see that I failed this Guardian a couple times. So I just decided that those attempts aren't worth showing. Alright, implications. Most people won't live without hot water for any length of time. That's true. That is very true. If there is no hot water in the house, people can't wash comfortably. Dishwashers and clothes washing machines will not work efficiently. You know, every now and then, it doesn't happen that often, thank God. Every now and then, whenever there is an issue with the hot water, damn, my family's just like, call someone to come check it out immediately. And then, to try to make them come faster and get the problem resolved faster, my dad is always like, and tell them we have a baby. We need hot water now. ASAP. When we damn well don't have a baby. I don't know, it's like to them. I know showering in cold water is uncomfortable. At least, like, you know, when you initially get in. But for me, it's like sometimes, well, if I have no choice, I'll take an ice cold shower. Sure, getting straight in is uncomfortable, but give it some time, you'll get used to it. Or you could just speed run lightning fast, shower in cold water, and just get it over with. You know? It's not that big of a deal. Anyway, strategy. As you perform your tests on the plumbing fixtures, you'll notice if there is no hot water. You may have been able to predict this based on your inspection of the water heater. Oh, this is a lot, but I should be able to read it all in about 6 minutes. Inadequate recovery. relative recovery rates. So lower to higher is electric, gas, oil. The amount of hot water available to a house is a function of two things. 1, how much hot water is stored in the tank. 2, how quickly the cold water can be heated. Size. Domestic water tanks are typically 20 to 60 gallons. 40-gallon tanks are quite common. Recovery rate. The recovery rate for a water heater is a measure of how many gallons of water can be heated by 90 degrees Fahrenheit, excuse me, or 32 degrees Celsius. Wait, no. Heated by 90 degrees Fahrenheit, bracket 32 degrees Celsius, or 100 degrees Fahrenheit, bracket 38 degrees Celsius in an hour. These numbers range from a low of 10 or 15 to a high of 100. Typically, recovery rates are in the 20 to 40 gallons per hour range, often roughly the same as the tank capacity on gas heaters. Implications. An undersized water heater is frustrating, and although the tank may be filled with hot water during 23 hours of the day... Oh, did you hear that? If there isn't enough water to allow everyone to have a shower in the morning, it's going to be considered inadequate. Oops, I just moved to the wrong slide. Hold on. Oh my god. Strategy. How much time do I have? Okay, 4 minutes. Strategy. Most home inspectors don't spend a lot of time interviewing their clients and trying to anticipate their lifestyles. We report on water heater sizes and give people an indication as to whether that's typical. If a family uses more hot water than average, a larger or second water heater will be necessary. Water heaters are not terribly expensive, and an undersized heater should not be a deterrent from buying an otherwise satisfactory house. Further, if the tank size is typical, a house usage family will probably have to add capacity in whatever home they buy. Jeez. I really butchered that sentence at the end. A high usage family will probably... Let me try that again. A high usage family will probably have to add capacity in whatever home they buy. There! And I think I should stop there for now. So, we are now on to slide 7 of 58. Oh my god, we have 50 slides to go through next time. Well, hope you enjoyed this one. More of me going through schoolwork. And yes, this will be the thing we do next time as well, because my midterm's coming up. Oh boy, what am I doing in game now? Going back to the next shrine? Great! And 10 seconds edited out. I'm curious. I'm not gonna take a look at myself. I'm curious how many loading screens I edited out, and just take an average. How much time did I edit out? Some of them were less than 10 seconds if I was quick traveling to an area close by, and some took as long as like 15 seconds. So I'm a little curious, you know? It's probably like maybe like 3 hours of time edited out. How many 10 seconds are in 3 hours? So obviously there's 6 10 seconds in a minute, and then times that by 60, and then times that by 3. That's 180 times... Wait. 180 times 6. 1080? I don't even know what I'm calculating anymore. I already lost my train of thought. I think this should be the last Korok I get for today. Yep, sometimes there is no quicker way than to just run over to it, unless you have the Master Psycho Zero, that is. I don't know, in my mind it always makes more sense, story-wise at least, to get the Koroks before the Master Psycho Zero. Now obviously the Master Psycho Zero would have been a significant help to getting all these Koroks, but hey, I've made my choice. So, as we're wrapping up here, thanks for watching, guys. I hope you bared with this one. And I'll see you guys next time.